I'm going to talk about COP2 pathways, and you might notice from this diagram that there's nothing specific about COP2 on it, so we're just going to make it so by decree. First thing that we'll do is identify a region in this diagram, circled here and here, and give it a name, the so-called ERES or ER exit site. And this is a real thing, I'm not making it up. It's a site of the ER that has been associated with high concentrations of cargo and the clustering of the components that will eventually become the COP2 coat. So it is as if there's a specific region of the ER that is just designed for shipping. The cargo accumulates there and is just continuously processed into the vesicular trafficking pathway. And then the other thing that we could do to make it specific is to identify a particular protein in that vicinity. That protein is called Sec12, and much more about that later. But for now, let's just say that it's here, and that defines the region that we're talking about. And I wanted to do that because I wanted to show you where it is on this diagram, because I think it's going to be hard to get your bearings from the diagrams that are coming up. Exactly where are we talking about? But I'm hoping that by the time we get all the way through the video, you can come back to this and say, yeah, that makes sense. And so here we go. So in terms of COP2 formation, this is more or less the way it happened. So again, here is the ERES, here is that Sec12 that I mentioned, here's the cargo that's going to be shipped, here's the cytoplasm. So in the floating around in the inactive form, but in the general vicinity of Sec12, is something that we identified on in a previous video, the protein SAR1 or SAR1P. So this D is going to give you a clue. It's the GDP bound form of a G protein that is a member of the ARF family. It's related but distinct from the ARFs. And the way that it's distinct is going to come into play right away. But what kicks the process off is the encounter between the inactive form of SAR1 and Sec12. And if I tell you what Sec12 is, you'll know immediately what's going to happen. What Sec12 is a GEF for SAR1. So once we just establish that, then we can move over to this part of the diagram, which is just this one turned 90 degrees. This is probably a bad idea, but let me just try to do that so that you can see what I'm talking about. Okay, so now we're in the book with Sec12 here, which they're identifying as SAR1 GEF, but they're the same things. And here's SAR1 in the inactive GDP bound form. So that interaction leads to what GEFs always do, nucleotide exchange, removing the GDP, replacing it with GTP, and that produces what we'll call the active form of SAR1, the GTP bound form. This is a GTPase, so there's going to be hydrolysis here, but it's going to take a while. And the first thing to establish is that this particular switch, moving to the on state, the GTP bound state, involves a conformational change that uncovers a region of SAR1 that's referred to by your book as an amphiphilic, most people call it an amphipathic alpha helix, that comes from the interior of the protein out into the wide world. Amphipathic or amphiphilic in the case of alpha helices means hydrophobic on one face and polar or charged on the other face. So this helix can lie really in and on the membrane of the ER such that the hydrophobic face is here and the polar face is here, and that serves as a reversible, fairly weak but significant anchor that keeps SAR1P, when it's GTP bound, on the surface of the ER where it does what it does next. And what it does next is recruit the components of the COP2 coat. It is itself part of the COP2 coat, but it recruits the rest of it. So before doing that, let's just talk about what that is, sort of skip to the end and go backwards. So the COP2 coat is SAR1 along with Sec23 and Sec24, and two proteins that interact with each other first, along with SAR1P, and then Sec13 and 31, two additional proteins that form the structure that is recognized as the coat, the outer layer of the COP2 coat. So we've got to build that using what we have done so far, which is activate small GTP protein. And the way that works is generally agreed upon. There's actually a lot of this that's controversial, but this part is agreed upon. And that is not that it goes straight to here, but that you go through a stage of coat formation in which SAR1P recruits Sec23 and Sec24 to the surface of the ER. They interact with each other and with SAR1P. Sec23 is pretty much engulfs or interacts with the entire surface of SAR1P, like so. But that interaction triggers the additional recruitment of Sec23-24 SAR1P, so that you end up with this layer of Sec23, Sec24 on the ER membrane. Some people think that itself causes curvature of the ER membrane, which is prerequisite to budding. Other people disagree. But in any case, what is agreed upon is that process produces what's referred to as a pre-budding complex, that is the arrangement of these proteins. And there's no cargo yet, so it's the formation of this pre-budding complex that alters the conformation of Sec24 here, so that the cargo binds to it. So if you imagine that as in cargo receptor and cargo, if you want, out here somewhere, then the process can be imagined as the fusion of this thing now to the sites that have been created as a result of the conformational change, so that you get the formation of these clusters of cargo. And you know, all of these cargos that I just drew are the same, but the reality is it can be a variety of different cargo molecules that are formed. So that brings us down to this part of the diagram from your text, and this is just two of what are going to be many of those Sec23, Sec24, SAR1P complexes, now with cargo receptors bound to it. One thing that's not mentioned on this diagram is that the Sec23, Sec24 pre-budding complex also recruits this light blue thing that we identified previously. That's the V-snare. In particular, it's the V-snare BET1P that is associated with the COP2 vesicles, and we'll deal with that in the next panel. But for now, let's proceed with the formation of the coat. So that begins as this bud. One thing or another causes this curvature. Again, it's not agreed upon, but in any case, by the time all of this coat complex through Sec13-31 is formed, you end up with coated vesicle. And this is what the coat looks like with everything else removed. So this is the Sec13-31 scaffold that serves as the outer layer of the COP2 coat. And this is the thing that leaves the ER, pinches off in such a way that you end up with coated vesicle that can then migrate towards the Golgi as it uncoats, as these things always do. So now about this GTP, so it turns out that Sec23 is a gap for SAR1P. So that association between Sec23 and SAR1 activates the GTPase activity of SAR1P, and that conversion of GTP to GDP ultimately is going to lead to the disassembly of the coat. Not directly, it's believed. It's a very strange relationship, the GTPase activity and the uncoating. It's not as simple as we've made it sound with the Rs, but in any case, ultimately that's going to inactivate SAR1 and lead to the dissociation of all of these complexes so that they can form a coat somewhere else. And that will allow the steps that are shown on the next slide to happen.